angles, counterweight, upper leaf or top leaf, and this is the bending leaf. Bending leaf is the thing that actually goes up and down on a radius to break your metal. And you want to make sure that when you set up a brake, or if it's new to you or it's been sitting a while or you're changing materials, that you set the clamping tension on the brake and the front nosing to be appropriate for the thickness of material that you're clamping and braking. And the general rule of thumb is these are 20-ounce copper sheets that I'm going to be using as a test strip. The general rule of thumb is you want the front nosing to be back from the bending leaf 2 thicknesses of the material that you're braking. And for exceptionally thin copper, like 16 ounce, 1.5 times the thickness. And you also want your front leaf to be 1 thickness of the metal below the anvil, which is the part of the brake that does not move and holds the material clamped with the top leaf. The way that you adjust the bending leaf up and down to get that clearance is you loosen all of these bolts. There's a set bolt on the bottom. Spin it up or down to adjust. If you need to go down, on this brake there is no adjustment screw for going down. So you have to take a block of wood and a mallet. You don't want to take a hammer directly to the top of the leaf, but you can drive it down after these have been loosened. For adjustment of the top leaf in and out for each thickness, there's a screw handle in the back here that will adjust it in and out. And that needs to be done whenever you change thicknesses of materials. And for zinc, for instance, which needs a more curved radius than copper would take. So you want to set that back. For zinc, I'd even go almost 3 thicknesses of the material that you're trying to break. And this adjusts very quickly. You just raise the clamping handle on each end, spin the knob, and it'll adjust the front nosing out or back in. Additionally, when you raise the brake on a properly tuned, when you raise the bending leaf on a properly tuned brake, you can look down through here and see daylight between the anvil, the part that doesn't move, and the bending leaf. And that gap should be about 1/16 of an inch, sometimes a little bit more, but it absolutely has to be uniform all the way across. If it's not uniform, you're not going to have a straight brake. For clamping pressure, the way that the clamping pressure adjusts is this big threaded bolt right here underneath the cam. Some brakes have the adjustment on top of the cam. This one is beneath. And the general rule of thumb is your clamping pressure wants to be just enough so that the sheet doesn't move and no more. The worst, most of the brakes that I see that have bending problems, people have set that clamping pressure so that you have to put nearly all of your body weight on that clamp to get it to seat. And that's way too much. That's going to distort your metal, especially copper, and you're going to have a hard time getting a proper brake. The other thing that, especially when I get a brake that's new to me, is I will release all tension on the truss rods. These are the truss rods that govern the straightness of the braking angles. There's 3 of those braking angles: the top leaf, the bending leaf, and the anvil leaf, which is underneath. So if you're buying a brake and you get it situated, bring it in your shop, take it off the wood that it's on, make sure that it's level in both directions and not twisted, and then take all of the tension off these truss rods by loosening these bolts. And then you'll see the steel deform over a day or 2. Then you can adjust it back to where it's bending straight. If you're bending copper that's like a banana when it comes out of the brake, you have a problem with the setting in these truss rod nuts. So take them all off. I see most often when you see a brake that has bending problems, the leaf is not adjusted correctly and somebody's cranked the hell out of these truss rod nuts. So I back them all the way off to see what needs to be done. In the back of the brake, there are 2 rods that come down to these angles, and these rods are simply tension rods that provide structure for this thing to press directly that way. These tension rods want to have just a little bit of tension on them. They're really not adjusting anything. You can see on this brake, if you come take a look at it after I'm done here, there's 1 nut, it's on this side, and it's barely threaded on there. There's maybe one thread sticking out the back of the nut. So these are just for strength, not for adjustment. So that's pretty much it. After you adjust it properly for the material, this brake is set up for this 20-ounce material. you can do a test brake to see how well the brake is operating. You don't need a 10-foot piece of metal that you're going to just waste. You can put these little 1-inch strips in there and clamp them down, one there, one in the middle, and one on the other end. Take it to a 90-degree bend, or close. And then compare the two on the ends to the one in the middle. I haven't done this yet this year, so they should all be the same, and they're pretty close. There's a little gap on the one, so I would adjust the bending leaf on the one end. That was the first one that I took out. So this side of the brake, the nose needs to come out or in a little bit. It looks like it needs to come in. It's a little bit overbroken. And then, yeah, you can take a 10-foot piece, put it in there. One thing to remember with a brake is when the brakes come from the factory, they're set up for bending their maximum capacity. And so there'll be an angle iron that's bolted to this front bending leaf. And if you take this angle iron off of here, like it's done on almost all of our brakes, I bet, that reduces the bending capacity of the brake by 4 gauges. With copper, we should pretty much never have a problem with these heavy ones, but if you're dealing with stainless steel or another heavy metal, you really probably want to put that front angle iron back on. It's integral to part of the brake. I thought they were added, by people that were trying to boost the capacity of the brake. Those are designed that way from the factory. So the angle iron is taken off here. And on that angle iron, the front leg comes out, so it doesn't go on the bottom. The front leg goes up to support that top of that bending leaf. One other thing that came up in conversation this weekend is how do you lubricate a brake or care for it? And if you look closely at the top of the pivot point for the bending leaf here, and on the top of the cam for the clamping action lever, there are small, what looks like a miniature grease zircon with a ball bearing in the center that's spring-loaded. That is not for grease. That's for 30-weight motor oil only. You should never use grease on a brake because it gets everywhere. And you guys have seen those little old-fashioned oil cans with the handle on it. The tip of one looks like a mushroom, and that is designed to fit these oil fittings. So I do mine whenever I remember, about once a month usually. They say to do it every day. I think that's probably overkill for most of us. And again, as little clamping pressure as possible. Have this adjusted so that if you notice on this side, I can put this in this side and it'll still move even after I have the handle down. Yeah, that one doesn't move now, but it did before. And that's okay, because when you're breaking a 10-foot piece, you're clamping all along the piece. You can actually raise the clamping action far enough that it does not hold the piece. And if you just hold it still while you're operating the bending leaf, you're going to get a really nice clean brake, because the brake is not dependent on the clamping action. It's just to hold it in place while the leaf does its work. Don't bend nails. Don't bend cleats. You can bend cleated material. You can hem material, but if you're doing nothing but hemming, you should bend all the hems first, and then when you close it up, you should adjust the brake so that it is set up for 2 thicknesses of the copper. If a common problem with these brakes is, and this brake has this problem right now, is you have front leaf creep or top leaf creep, where when you set the handle down hard, it'll jolt the nosing out and bring you off your mark. And the reason for that is there's a barrel fitting in here that has too much play and wear in it. And so some washers have been added to the left side of this to remove that. No washers have been added to the other side, and that side has much more creep to it. And this brake is probably out of level as well. So if you have top leaf creep, check to make sure that there's no backlash in the screw operation. If there is, add washers to take it out, and then level the brake. All of the manuals say if you're having creep on the front leaf, on the top leaf, the brake is not level, front to back, in this direction. And the brake should be level in both directions and not twisted. So you want to, and whatever shims you want to use should be metal so that they don't compress. That's pretty much, so this brake in particular, it bends nice and straight. It's set up nice for clamping, but we need to take apart and install some washers on the back side there to take out that creep and probably level the brake. We'll need a pretty good sized jack to lift this thing up. Any questions? I mean, that's pretty much it. They're pretty simple machines. If you do have a bowed front leaf where your line of sight is about 1/16 of an inch here, and in the middle, it might be 3/16 or 1/4 inch, that brake is sprung. And so if you're looking at a brake to buy, you wouldn't want to buy a sprung brake because you really can't take that out without some very expensive tooling. Once you spring a brake by bending something that's too heavy, you deform the front leaf and it's not going to work right anymore. Same thing if you over tighten these truss rod nuts, you can permanently disfigure and deform the metal of the brake. So be very careful when you are doing that adjustment, that you're just doing it enough to take the banana out of the metal. One other thing to remember with brakes is if you're using a rotary slitter and you're making an L-shaped bend where the slit end is the short leg of the L, it will deform in the brake. And that's not the fault of the brake, that's the fault of the slitter as it deforms the metal in the short dimensions. So if you can, shears are the best way to slit metal so that it's not deforming the brake. You probably notice that if you cut metal with a hand shear and then put it in the brake, it's a very skinny piece, it's not going to break up right for you. So try and use a foot shear if you can. Anybody have any questions, things that you've seen on your brake that you want to know how to fix?
So you're saying when you're doing the hem, you make all your bends first, and then before you clamp it down, you open up so it's twice as thick, and then...
That's correct, yeah. Usually when you're hemming, you're doing quite a bit. If you do a few, it's not too bad. The other thing is if you're braking repeated short pieces, a 10-foot brake, and let's say you've got to do an 8-foot section because you have an 8-foot bed in your truck and you want to carry the parts that you break in the truck, it has to be centered on the brake. If you only do, hundreds of 8-foot pieces on that side, it will eventually put the brake out of adjustment because they're designed to be symmetrical. So I'd want to center that 8-foot piece 1 foot from this side, 1 foot from that side. Even if I'm doing a 3-foot piece, I would still want to center it in the brake. Because if you put a 3-foot piece here and it ends right there, you're going to notice real quickly that it breaks different on each end. So if you center it up, you'll get a much more symmetrical brake. Both sides should be the same. Any other questions?
You got that bolted to the floor?
It is not bolted to the floor, it should be. Good question. And that's the nice thing, if the brake is toward, like when my shop, the floor is so out of level that I have it sitting up on steel plates on one end about 2.5 inches and the other end sitting on the concrete, and I needed to bolt it down to take the twist out of my brake. So it's just like a lathe or a foot shear. It really should be bolted down and shimmed up where necessary. The other thing is, if you look at this brake here, it needs a little bit of adjustment there, or probably just some lubrication. When you set the counterweights, these are on beveled arms so that you can offset the counterweight towards the front of the brake or towards the rear. What that does is change the balance point on the bending leaf. That balance point should be, when you let go of it, it should return to the vertical position naturally. I think this one will once we give it some lubrication, but if I just raise that and let it fall back naturally, you can see that it's always going to return to the vertical position. If it does not turn to the vertical position, like the 8-foot 10 Smith in there, if you're not careful or you bump the counterweight, you can now clamp in a piece of metal, and while you're clamping it in, you're going to put a brake in it, because right now the bending leaf is above the anvil portion of the brake. So I would take and loosen this bolt. In fact, I'll probably do this later on. Loosen these 2 bolts and swing the counterweight away from the brake to lower this back down. And if it's too far, if the brake becomes too heavy, you can rotate the counterweight towards the back of the brake and it will balance out the leaf. This 10-foot brake is pretty heavy, and you can lift that with a single finger. It's pretty easy to operate.